Hey, in this class we're going to look at what a limit is, how to write it down, so basically the notation, and how it works and what makes it invalid. So basically, if I write the limit, so when we write limit, we write lim. There's no it in it, because we don't need that. Everyone understands that lim is limit. So when I say the limit as x goes to 1 of f of x, that means whatever function you have, I'm going to actually draw this down, but let's say you had a graph, and then you had a function, whatever it is, and then as x approaches 1, means that, let's say 1 is here, so this is the x-axis, and this is the y-axis, so as x goes to 1, what is the value of y? So we have to go from the right and the left to reach the value of 1. Let's say this was at, if this line is at y is equal to 2, that means as x approaches 1 of the function f of x, which is this, so I'm going to write it in pink actually, but this is f of x. So as x approaches 1 from the right and from the left, y approaches 2. So this is going to be equal to 2. So that's the notation of it. It just basically means this is what you're approaching, and this is what you're following, because you have to trace the function from both the right and the left. That's how you find a limit. Something else that you might see is the left limit and the right limit. You can probably already guess what that means, but if I write the limit as x goes to 1, and then like a small negative sign on top of f of x, this means you're going to follow this pattern and see where it goes to the left of x, basically the negatives. So instead of having the right and the left, we're only going to look at the left right now. This might seem like it's a bit unnecessary for now, but actually makes a big difference later. So in this case, it's the same thing, but if x goes to this value from the left side, this value is equal to 2. Because once again, as x approaches 1 from the left, it goes to this value, which is equal to 2. So that's that. And then similarly, you're going to have limit of as x approaches 1 from the positives, from the right side of f of x. Once again, this is very similar, but we've already done the left side. Now if you follow the right side, I'm going to do it in orange. You're going to go this way as x approaches 1. You're going to go down the curve, and then you're still going to get the same value, which is 2. So the answer you get is what the y value is at that point. In this case, in this scenario, the y value was the same as the function value. The limit landed on where the function is, but that's not going to always be the case. We're going to look at that later as well. And for the limit of a function to exist, let's say if I want to find the limit as x goes to 1 of f of x, both of these have to be the same number. Since they are both 2, the answer is equal to 2. In some other question, I'm going to write it down. If the limit as x goes to 1 from the negative side of f of x was, let's say, 1, and then the limit as x goes to 1 from the positive side of f of x, it was equal to 2, then the limit as x approaches 1 of f of x would be does not exist, DNE. Once again, this is because the limit from the left is 1 and the limit from the right is 2. They're not the same. They don't approach the same point on the graph. That means the limit as you go to that point does not exist. You don't have a limit and it's invalid. So that's one way of being invalid. Another way is getting infinity. So let's say the limit as x approaches 1 is of f of x is infinity or negative infinity. These also both, you can substitute them for DNE, does not exist, but yeah, they just mean that you don't know where exactly it goes, so you can't really give an answer. It's invalid, but it's a bit more descriptive than writing DNE, because at least you know, let's say as if if you had a graph with an asymptote, so I'm going to do it here. So this is the asymptote at 1, and let's say both of them were going this way. So x goes to negative infinity as you approach 1. This is a bit more descriptive than writing DNE, because you now at least know that they're going down. they're not going up or something else. So, but yeah, so infinity and negative infinity also mean DNE, but it's a bit more descriptive than actually writing DNE. So that's basically it for the explanation. Let's move on to 2 examples of finding an answer for any limit. Okay, question number 1. Here we have the function f of x is equal to x, or in other words, y is equal to x. This is the most basic linear function you can ever have. But yeah, so you can even see the pink line over here is the function. So if I ask you, what is the limit as x approaches 1 from the left side? So when you see this small negative sign, you want to think about coming from the left. So you want to go from left to right, from the negatives to the positive, from the left side. So what is the limit as x goes from the left side to 1? This would be, you have to follow this line, so you can go up from left to right and stop at 1. What is this point? It's equal to 1, because when x is 1, y is 1. We know that from the function. So if y is equal to 1, that means y is 1, and that's it. Because x is 1, that means y is 1. So here we know that this is 1. And now let's go from the right side, because it's the same question, but now we have to check it from the right side. So you'd once again follow it from right to left this time. So going this direction, from right to left, and seeing what the function value approaches at 1 from the right side. So as you go to 1 is over here, as you go to it, the function or the value of y approaches 1 as well. So this is 1. Okay, and since both of these are equal, since the left limit is equal to the right limit, then the limit of 1 in both directions combined is the same thing. So once again, if both of these are the same, this is going to be the same. So I'm going to recap this. If the left limit and the right limit are the exact same, then the limit as you approach that value is also the exact same, because it cannot change. No matter where you approach it from, you always get the same value, so that's how it works. That's basically the limit of this as x approaches 1 from the left, right, and combined. Let's do the exact same thing this time, but for negative 1. So as x, I'm going to erase all these notes we have here, because we don't need them anymore. But yeah, so let's start over basically. So as x approaches negative 1, first let's mark negative 1, it's over here. And negative 1 is kind of like over here on the function. And then as you approach it from the left side, because there's a small negative here, so as you approach it from the left side, so from left to right, the value of y is negative 1. So that's pretty simple. So negative 1. And also as you approach it from the right side, so let's go from right to left, basically from top to bottom this way, the value of y is also negative 1. And since this is equal to this, the answer of the limit as x approaches negative 1 of the function is negative 1 as well, because they all should be equal. And that's it. That's how you find limits. You basically, in real life, I can't really show you this because it's on a piece of paper, but in real life, you're supposed to take both of your fingers and move towards the point you are trying to find the limit for. And in this case, I'm drawing with the arrows. I'm going to erase the arrows and redraw them. But yeah, so in real life, you would have one finger going this way towards the point you're going to, then the other finger going this way towards the same exact point, and seeing if the limit is going to the same place, if basically your fingers touch. So that's it. Okay, let's move on to the next example, which is going to be a lot more complicated. Okay, question number 2. This time we have a piecewise function, and before starting, let's analyze this a bit. So first, when x is less than negative 1, so when it's less than this, the function is equal to x minus 1. That's the value of the function for this orange part over here, when x is less than negative 1. When x is between negative 1 and 5, so this part, the value of y is x. So the function follows the value of just x. Imagine the linear graph or linear function we saw from the last time, but only a piece of it. And that piece is between negative 1 and 5. But also one more thing, negative 1 is included. That's why this is a closed circle. And negative 1 for the orange was actually an open circle, because this is only less than. This is less than or equal to. So that's that. And over here, the hole is open because it's only less than. It's not less than or equal to. It's only less than. So the hole is open, and basically the point at that area does not exist where you think it should exist. And then same thing, so if x is greater than 5, basically this part, you would have this function x minus 5 squared plus 5. So that's that. And then in the one last point of the entire graph, when x is equal to 5, the function exists over here, which is 10. So that's it. You have basically 4 parts. First, it's less than 1. And then you have between less than negative 1 was the first part. And then between negative 1 and 5. And then greater than 5. And then at 5. And then at negative 1, we know it because this is a closed dot, which is on the pink line. But yeah, that's that. Let's actually try to find a few limits now. So the first one says, what is the limit as x approaches 5 from the left side? So first of all, where is 5? You need to mark it. It is over here. So that's 5. If you approach it from the left side, what is the value that you would get? If you go this way, you might say, okay, if you go this way, the value of the function is over here. You'd be wrong. The limit isn't always equal to the value of the function. In this case, if you trace your finger, in real life, you're not going to jump up once you get to the spot. Your finger is going to stay here once you get there, because a limit is the value you are approaching. It's not the value that the function is equal to. It's the value that you're getting towards, that you're going towards. So the function over here would be equal to 5. This is the limit for the first one. So as x approaches 5 from the left side, the value of it should be 5. But it's not equal to 5 because we can see it here. It's actually equal to 10, but it should be 5 because that's what it's approaching. And then if it approaches 5 from the right side, same thing. So you go from this way, kind of following the blue curve. But as it approaches 5 from the right side, you still approach the same value, which is equal to 5. So in this case, since the left limit and right limit are the exact same, the limit as x approaches 5 in general should also be the exact same. And this also tells you, if I did not ask you for these two, let's say I'm going to cross these out, I didn't ask you for them in the question, and you wanted to find this, part of it is actually finding these two. These are intermediate steps to find the bigger, more general limit, because you're trying to see if they are the same or not. If they are the same, then this is the same. If they're not the same, then this does not exist, as we have talked about before. But yeah, so once again, the first two are intermediate steps for the final one. But yeah, that's the first kind of question pair up, or triple pair up, whatever you want to call it. Okay, now let's do the exact same thing for the next part of the question. So I erase something, let me bring it back. Okay, but yeah, this time I'm going to solve these 3 questions. This time I'm going to look at as x approaches negative 1. This is now our point of interest. If you want to mark where negative 1 is, let's do that first. So I'm going to do it in purple, but it will be over here. This is x at negative 1, and you are basically looking at this entire kind of area or region to solve your answers. So as x approaches negative 1 from the left side, you have to go from the orange line, because that's the left side. You go from bottom to top this way, so from the left to the right. If you keep going, you would approach negative 2 when x is equal to negative 1. So let me repeat that again. But as you I'm going to put like a vertical line. As you approach the vertical line, you get to the value of negative 2 for y. Because you are approaching it, once again, it's not what the value of the function is equal to, it's what the value of the function you are approaching. So in this case, you are approaching negative 2, the open hole that you see over here. I'm going to circle it again. It's this part, the open orange hole. But yeah, that is equal to negative 2. Okay, let's do the exact same thing from the right. If you are approaching negative 1 from the right, let's try this. You would follow the pink line. So from right to left, you go this way. And if you keep going, once you get to this vertical line again, this time we're going to look at the pink closed loop. But in this case, the value of the function is over here. And the limit as x approaches the function at negative 1 from the right side is the same thing, which is equal to negative 1. So quick recap, the value of the limit as x approaches from the left side is over here. As you approach it from the right side, it's barely on top of it, but it's not the same. So in this case, they're actually not the same, and that's why if you have the final limit as x approaches negative 1 in general, this is going to be does not exist, because these are not the same. They have to be the same for this to be an actual value, but if they're not the same, then does not exist. And a couple things you could have noticed, in the first kind of group of questions, we don't really care where the function is equal to. We only care about what it is approaching. That is our main concern. So once again, you don't care about what the function is equal to at that point. You want to know what the function is approaching at that point. Same for this, but in this case, the closed hole was actually one of the limits, so it was kind of convenient. But once again, you care about what it's approaching, not what it is equal to. And that's it. That's basically what a limit is in a nutshell. You just have to kind of trace your fingers and move to the point where you want to go to from either left or right or both. So yeah, that's basically what a limit is.